Hi, I'm Miss Jones, and I'm here to walk you through the worksheet, Scientific Notation. We'll be using the notes while I use scientific notation, and you can either type your answers in, or if you print out the worksheet, you can write the answers down. I'll be showing you both ways. So the first question lines up perfectly with the first slide. Why use scientific notation? We also call scientific notation powers of 10. And the reason why we use it is so that we can work with very large numbers or very small numbers. So for example, the speed of light is 299,792,458 meters per second. It's super frustrating to memorize that, especially if you have to use it a lot, so we normally just say it's 3 times 10 to the 8th meters per second. It's almost the same number, it's just rounded. And it's a lot shorter and easier to use. We also use a lot of really tiny numbers. The mass of a proton is 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 1.6726219 times 10 to the negative 27. And so the main purpose of scientific notation is to write very large numbers or very small numbers so that they are easier to use. So you would write that here in a complete sentence, or you would write that here by hand in a complete sentence. So for that first one, I'm not going to tell you the answer because I already have. Moving on to the next slide. These are the two things that are always true of a number that is written in scientific notation. So first, it has to be a single-digit number before the decimal point. So here's some examples. 1.24, 4.68, 9.0, 4.567. All right, so that point, that decimal point, should only have one digit to the left. So some of the examples of being incorrect, 12.4, this one has 2 digits to the left. 0.468, 0 does not count as a digit in this case, and so this is not a digit on the left. 900, this doesn't even have the decimal showing. It would be right here, but it's not there, so this does not have one single digit to the left. It has 3. You'll see this one has 2 numbers to the left of the decimal point, so these are all incorrect. So the first, number one, most important thing for a number that is correctly written in scientific notation is that it has a single digit number to the left of the decimal point. You could also write that here, one single digit number before the decimal point. So you see how I'm kind of writing it in shorthand because these are handwritten notes, while if I was typing it up, I would be a little more exact. So let's take a look. What is the second rule? So in order for it to be in scientific notation, it needs to be multiplied by 10 to an exponent that is in a whole number. So what that means is it would be times 10 with an exponent of 4. And I usually call this times 10 to the 4. So, or times 10 to the negative 2, also known as times 10 exponent negative 2. It could even be times 10 to the 97. The number up here could be as big as you want as long as it's a whole number. It can also be negative as long as it's a whole number. So all of these are correct ways to show that. Incorrect ways would be if instead of times 10 you used a different number. That's not in scientific notation. Another way would be if the number was not a whole number. So 2.1 has a decimal in it. That's not a whole number, and so that would not work for this scientific notation. If it's just times 10 by itself, it doesn't have a number in the exponent, that's not correct. Again, if it's not a 10, then it's not correct. If it's not a 10, even if it has an exponent or doesn't have an exponent, it's not correct. And even times 100 would not be correct. You could change this to be in scientific notation by just changing it to 10 to the 2, or with exponent 2, but these are not written correctly in scientific format. And so the correct answer would be multiplied by 10 with exponent that is a whole number. And again, you could also write it here, times 10 with an exponent that is a whole number. All right, let's take a look at the next step. Using those two rules, we're going to look at these numbers and figure out which ones are correctly written in scientific notations and which ones are not. So if you are doing this by hand, you're going to be circling any of the ones that are correctly written in scientific notation, and you're going to be crossing out the ones that are not correctly written in scientific notation. If you're doing this on the computer, to highlight, all you do is you select it with your mouse, and if you look up here, you'll see that there is a highlight button, and I usually prefer yellow. If you made a mistake, you can change it back to none. So let's take a look at a couple of these to see which ones are correct. So the first rule is they can only have one number to the left of the decimal point. The second rule is it has to be times 10 to a whole number. So let's take a look at these and find out which ones are not correct. If you look at this, does this only have one number to the left of the decimal point? If it does, circle it. If it doesn't, then you're going to place an X over it if you're writing, or I'll show you how to strike through. You hold Alt, Shift, and 5. Once you've highlighted it, that's Alt, Shift, and then 5. And that will cause it to strike through or cross it out. If you make a mistake, you can just go back and Alt, Shift, 5 again, and that will get rid of the strike through. So you're going to look at each of these numbers and you're going to check, does it have a single digit number to the left of the decimal point? Any of the ones that don't, you should cross out or strike through. The second rule is the number in the exponent a whole number, and is it being multiplied by 10? So all of these seem to be multiplied by 10, so that's good. But now you're going to look up here. Is this a whole number? Negatives are okay, but decimals are not. So go ahead and look through these 8 scientific numbers and cross out any of the ones that are incorrectly written and highlight or circle the ones that are correctly written. Let's take a break from the worksheet for a moment, and let's just learn a little bit more about what these powers mean. So for example, a power of 10, that exponent indicates the number of times that 10 is multiplied by itself. So for example, if you have 100, most of you should know that 100 is 10 times 10. So if that's 10 multiplied by itself 2 times, then you can also write that as 10 to the 2. Similarly, if you look at 1,000,000, that is 10 times 10 times 10 times 10 times 10 times 10. That's 6 tens. And so you could write it as 10 to the 6. Now you don't always have to write out 10 by 10 by 10 by 10 to try to figure out how many tens it would be. Instead, just count the number of zeros. So if you see 10,000, it's a 1 and it has 4 zeros. So that can be written as 10 to the 4. You can also write the number 1 and the number 10 in the same format. So for example, a 1 is a 10 with no zeros. It's just the 1. And so you can actually say 10 to the 0 when you're talking about the number 1. There are some situations where that would actually be useful. The number 10 itself is a 10 that has 1 zero. And so you can write that as 10 to the 1. And these can be useful in rare circumstances. If you want to write a number like 300, the easiest way to do that is to break it out into two parts. 300 is 3 times 100. We know that 100 is 10 times 10, or 10 to the 2, and so you could just write it as 3 times 10 to the 2. If a number gets more complicated, it's basically the same. 352 is 3.52 times 100, and so you can write that as 3.52 times 10 to the 2. You know that it's in the hundreds place because of that 2. Now, one of the other things that scientific notation is really good with are numbers that are less than 1. You can write very small numbers using powers of 10. So, for example, if you have 0.01, you could say that as 1/100th, and you can change that 100 to be 10 to the 2. And so it would be 1 over 10 to the 2. Now, we can actually turn that into scientific notation by writing it as 10 to the negative 2. Because if you have an exponent on the bottom of a fraction, you can move it to the top by changing the sign of the exponent. So 10 to the 2 on the bottom of a fraction becomes 10 to the negative 2 on the top. 0.0001 can be written as 10 to the negative 4. And I'll show you a trick for figuring that out on the next slide. You can write a number like 0.00052. That is 5.2 times 0.0001, and so you could write it as 5.2 times 10 to the negative 4. All numbers that are less than 1, the power is going to be 1 more than the number of zeros to the right. So if you look here, there's only 3 zeros to the right of that decimal point. But it ended up being a power to the negative 4. And that's because in order to move this decimal point so that it has one whole number digit, single digit, to the left, you have to pass all of those zeros and that additional number. And so that's why, if you were moving this over until you only have one number to the left of the decimal point, you would have to move it 4 times to get there. Now, sometimes it might be hard to tell the difference between what does the positive exponent mean, what does the negative exponent mean, and here is how you can tell. If you have to move the decimal point left, then that means the exponent is going to be positive, and that's because you're dealing with a number that is more than 1. And so if you see a positive exponent, then this number is more than 1. If you have to move the decimal to the right, in order to create your scientific notation, you're going to end up with a negative exponent, and that's because the number you're dealing with is less than 1. So, if you move the decimal left, you're adding positive numbers to the power of 10, and this is for numbers greater than 1. So, for example, if you have 12,345, here is a hidden decimal point. It's always hiding right at the end of a number if you don't see it. In order to convert that to scientific notation, you only want this single digit number to the left of the decimal, and so you're going to end up putting the decimal point there. In order to move it there, you have to start from here and go 1, 2, 3, 4 to the left. And so when you have to move it to the left, this number is going to be positive. And so if you're converting a number that is more than 1 into scientific notation, its exponent will be a positive number. Now, if you end up having to move the decimal to the right, that means you're adding negative numbers to the power of 10. And this is what you do when you have a number that is less than 1. So, for example, if you have 0.000122345, in order to move this decimal so that there's a single digit to the left you have to take this decimal and move it to the right 1, 2, 3, 4 times. And so this time you're dealing with a number that's less than 1. You're going to end up with a negative exponent. It had to move to the right 4 times to get there, and so you put 10 to the negative 4. If you had to undo scientific notation, so for example, if you had 5.678 times 10 to the 3, when you're undoing scientific notation, you go in the opposite direction. Here's positive. You're going to be moving this decimal to the right 3 times. While this one is negative, you're going to be moving the decimal to the left 3 times. So, if you see a negative number, then that means the original number, if you see a negative number in the exponent, that means the original number was less than 1. If you see a positive number in the exponent, then that means the original number was more than 1. Let's take a look at the worksheet now and write down what does a positive exponent mean and what does a negative exponent mean. So, here we have what does a positive exponent mean. This means that we're dealing with a number that is more than 1, and you will be moving the decimal place to the left. While here, a negative exponent is a number that is less than 1, and you move the decimal place to the right. Okay, so if that's true, then let's go ahead and take a look at these practice problems. Now these numbers here are identical except the exponent is either positive or negative. So you see these, all of these are positive, and if you see this, all of these are negative. And same over here. All of these are positive, all of these are negative. If you go through, I will fix that one for you guys. And it should be before it. There we go. Yay! If you guys look at all of these, you can tell that if this is correct, then the original number must be less than 1. While if this is correct, the original number must be more than 1. It doesn't matter if the number itself is negative or positive. This doesn't matter. What matters is if the exponent is negative or positive. So, let's take a look at the first one. Is 1,280,000 more than 1? If it is, then this would be the correct answer, and you would highlight that, or circle it. If it's less than 1, then you would highlight this one, because it has the negative exponent. And so for this one, you're just going to go through, if the number is less than 1, and you double check, and in order to get this decimal to be over here, so that there's only one whole number to the left, you had to move left to get there, then that would mean that is a positive exponent. Let's check this one. Is this one more than 1 or is it less than 1? If you see it start with 0 point, then you know that it's less than 1, and you know that it has to have a negative exponent. And so any of these numbers that start with 0 point, that gives you a clue that you should be seeing a negative exponent. So when you go through here, I can tell you now, this one is from a number that's more than 1. And so this is the correct answer. While this one is from a number that's less than 1, which means this is the correct answer. So you're going to go through and do that for all of the rest of these questions. If you're doing that on paper, then you're going to be circling the ones that are correct. This had a positive exponent because this is more than 1. And this one has a negative exponent because this one is less than 1. All right, let's go ahead and you can finish those. And then we're going to practice a bit with writing out numbers in scientific notation. All right, so if we're going to write this first number, 230 million, in scientific notation, if you're typing it, then this is how you would go about that. First, you write down all of the numbers except for the zeros. Then you find where the decimal point is in this number. Now, if you'll notice, you don't see a decimal point. You see commas, and the commas are just there to help you separate the number into thirds so it's easier to see where the digits are. But you don't see the decimal point. But if you saw my hint earlier in one of the slides, if you don't see a decimal, then it's a regular whole number, and there is a hidden decimal at the end. And so let's take a look. There must be a hidden decimal here at the end after that final 0. How many times do you have to move that decimal point until it leaves us with one single digit to the left of that decimal? So we know that this is going to end up being 2.3 times 10 to the what? Alright, and you can actually go through and set up these. I'll do these first two. So this would be 6.65 times 10 to the something. And you could do that for all of these. If you notice this one, the first number that isn't a 0 is 8. So that would be 8.9 times 10 to the something. And let's take a look. How many times does this invisible decimal point have to move to the left until it gets to this spot between the 2 and the 3? So let's count. It has to go 1, 2, 3, 4, 5, 6, 7, 8. So that means it's times 10 to the 8th. Now you could write it with the caret symbol, which is on the number 6, and then say 8. Or, since you're on a computer, you might as well use superscript, which is what it's called when it's nice and small in the top. And you do that, put your cursor where it needs to be. You're going to type Control and then the period, and that moves up the cursor. You see how it got smaller and higher up? And then you can go ahead and type in the 8. And then if you need to type after that, you'll notice it'll be really tiny. So you can always go back in, and after your 8, you just push Control and then period again. So that's how you do superscript on Google Docs. But let's say you're doing this by hand. It's actually sometimes easier to do it by hand, because you can just write the little decimal there and go to the left until you get only one digit to the left of the little decimal point. And then you can see that it should be 2.3. And then however many times you had to jump to the left, that is how many numbers are going to be after times 10 to the what. So 1, 2, 3, 4, 5, 6, 7, 8. Remember, ignore the commas. They're just there for visual cues. So this is times 10 to the 8th. This one, it's showing you the decimal point. There isn't a hidden decimal point because it's actually showing you the real decimal point. How many times do you have to move this so that there's only one digit like this to the left of the decimal point? Let's find out. 1, 2, 3, 4. And so that would be times 10 to the 4. Now this one, you notice, if you move to the left, you don't get any whole numbers. You need at least one regular non-zero number to the left of the decimal point. So in order to do that, in order to get 8.9, you actually have to move to the right. So 1, 2, 3, 4 in order to get there, which means this is times 10 to the negative 4 because it moved to the right. And so you should see, you should be able to double check. This is a number that's more than 1. I have a positive integer in my exponent. This is a number that's more than 1. I have a positive. This is a number that's less than 1. I have a negative. So you're going to do this for the rest of the numbers on the side of the worksheet. Now that you're familiar with how to create a scientific number in scientific notation, what happens when you have to add or subtract those numbers? Now, believe it or not, adding and subtracting is actually just a little bit more difficult than the multiplying and the dividing. And so let's take a look. You get lucky if they have the same exponent. So for example, if it's 2 times 10 to the 4 plus 3 times 10 to the 4, then you actually just have to add those numbers in the beginning. So it's 2 plus 3. And then you still keep the times 10 to the 4. If you're familiar with algebra, this would be similar to saying 2a plus 3a equals 5a, where a would just be this. But if you're not familiar with algebra, just know that if these exponents are the same, you can just add the numbers in front if they're adding the two numbers. And so 2 plus 3 equals 5, and so it would be 5. And you just keep the same times 10 to the 4. If you're subtracting, so it would be the exact same thing. Luckily, both of these numbers have 10 to the 6th, 10 to the 6th. And so you can just say 7 minus 3. 7 minus 3 is 4. And so it would be 4 times 10 to the 6th. But sometimes you will come across numbers that don't have the same exponent. And so what you're going to need to do is adjust the number with the smaller exponent so that it matches the same exponent that the larger one has. So for example, if you have 2 times 10 to the 3, and you have 3.6 times 10 to the 5, then you're going to need to convert this 10 to the 3 over to a 10 to the 5 in order to use these numbers that are in the front. And so you need to convert this number so that it is 2 times 10 to the 5, but that wouldn't be the exact same, so this will have to change if this changes. So I know that you will have to end up moving the decimal point 2 times to the left. So I'll show you guys why that's the case. We're starting with the number 2 times 10 to the 3. Now what is that number if you just write it out as normal? That would be a 2 with 3 zeros. So if we need something times 10 to the 5, but it still needs to be this number, then let's change this to times 10 to the 5 by putting that decimal point there and then moving it. So let's try it out. We have the 2 with 3 zeros. 1, 2, 3, 4, 5. So it actually ends up being 0.02 times 10 to the 5. Now this is not a number that's correctly written in scientific notation, but it is a number that's times 10 to the 5, and so temporarily we can use it in our calculations. So let's take a look. We have 0.02 times 10 to the 5, and we have 3.6 times 10 to the 5. So now that they have the same exponent, we can just add those numbers at the beginning. So 3.6 plus 0.02 is 3.62. And now we add on the exponents powers of 10 at the end, and we have 3.62 times 10 to the 5. The reason why we always move from the smaller exponent to the larger exponent is because usually this will mean that we don't have to do another adjustment at the end to put this into correct scientific notation format. Most likely, the final answer is still going to be in the same exponent as the larger number most of the time. So, you take the smaller number, even if this here was a 15, this would still be a smaller number because of the exponent being smaller. You take the smaller number, adjust it to be the same exponent as the bigger number, and then you can add them together. So let's take a look at the worksheet and look at the example that's in there. This first one, they both have the same exponent and they're being added together. So luckily, we just have to add the numbers that are in front together. And so this one would be, and in order to show your work, you've got to type it out. You would have 3 plus 3 times 10 to the 5. And you can either do the caret like that, or remember you can highlight that number and go control period, and that'll turn it into that little 5, and you can get rid of that caret. And so your answer would be 6 times 10 to the 5. Now let's take a look at the next one, and I'll do this one by hand. This next one is a subtraction problem, but if you'll notice they don't have the same exponent. This one is an 8, and this one is a 7. And so which one do we need to adjust? We need to adjust the smaller one so that it has the same exponent as the bigger one. So the first thing that we're going to need to do is we're going to convert this to times 10 to the 8th. Now to go from 7 to 8, remember it's getting smaller, or that this is a smaller number, and so we're going to be moving the digit over to the left. And so instead of 5, we could just call this 0.5 times 10 to the 8th. That way it's got the same. Alright, so if we have 4 and 0.5, we can actually go 4 minus 0.5, and we still have times 10 to the 8th. So what is 4 minus 1/2? The answer would be 3.5 times 10 to the 8th. Alright, so just to recap, this was just the number 5, and this was times 10 to the 7th. In order to get this to be something times 10 to the 8th, we had to move this decimal place over in order to add another number up there. Alright, so that's it for the positive and the negative. You'll notice the next one has multiply and divide. So let's take a look at the notes for that. So if you're multiplying or dividing, then it's actually easier because you don't have to change them so that they're the same. The rule is very simple. When you're multiplying, you're just adding the powers together. Well, if you're dividing, you're subtracting the powers. So if you have 10 to the 3 times 10 to the 2, you would actually write that as 10 to the 3 plus 2. Let me go ahead and make that nice and little like that, so it looks like that. And so that would be 10 to the 5. So if you have a full number in scientific notation, so 2 times 10 to the 8th times another scientific number, 3 times 10 to the 7, you can actually separate it so that you can work with it. You still have 2 times 3, but you can put these over together, 10 to the 8th times 10 to the 7, which ends up being 10 to the 8 plus 7. And 8 plus 7 is 15, 2 times 3 is 6, and so the 2 times 3 becomes 6, and this becomes 8 plus 7, which is 15. And so if you write this down, it should help you out. 10 to the a times 10 to the b is 10 to the a plus b. Divide is similar. It works like this, so you get 10 to the 5 divided by 10 to the 3 is the same as saying 10 to the 5 minus 3, which would be 10 squared. So 10 to the a divided by 10 to the b is the same as saying 10 to the a minus b. Let's take a look at the worksheet. And here's a multiplied one. And so to show our work for this, let's group the numbers in front. So we have 6 times 2. And then let's group the times 10. And you can either use the caret symbol, but I highly recommend using control period. And we've got 3 and 6. So 3 plus 6. And then use the control period to go back down when you're going to do that. Alright, so you've got 6 times 2, and you've got 10 to the 3 plus 6. So what is 6 plus 2? That is, actually let's start out over here, equals 12. And you have times 10 to the what? What is 3 plus 6? 9. Now, is this number in scientific notation? Is this a single-digit number before a decimal? No. So if I have to add another decimal there by moving it to the left, I'm making this number here, I'm adding 1 to the exponent. So the actual answer for this one would be 1.2 times 10 to the 10. For this next one, we have a divide, and so that means we're going to be subtracting. I'll show you how to set this up. So you take the numbers in the front, 9 divided by 4.5, and it's going to be the same times 10 to the, and this time it's going to be 12 minus 7. So if you can see where I got each of those from, this divide symbol is still here, and instead of adding these exponents, I'm subtracting them. And so when you have this in your answer, it's already going to be in scientific notation, and so you should be able to write it out just fine. I'm not going to show you the answer for that one. But let's take a look at the next slide so we can learn how to take of power to a power. If you've got a number that's in power of 10 and you need to raise it to a power, now we're going to be multiplying the powers together. So this is definitely something you're going to need to have written down to remind yourself, because when you multiply numbers that are in power of 10, you have to add them, while if you raise them, you have to multiply them, and so it could get kind of confusing if you don't write this down. So when you raise a number to a power, you're multiplying it. So 10 to the third to the fourth, so 10 with 3 as the exponent raised to another 4 as the exponent, that's when you're actually multiplying them together. So writing this down in your notes would be super useful. 10 to the a to the b is the same as saying 10 to the a times b. Now, if it's a numbered scientific notation, and so you have a number at the front, you can't forget that this is being distributed to both of these chunks. And so you're doing 10 to the 2 to the 3, but you also have this 3 going down to this 4. So what you would have is 4 cubed, or to the 3, with exponent 3, times 10 squared, also cubed, to the 3. And so 4 cubed is 64, because 4 times 4 times 4. And here we have 2 times 3, and so that one we are actually multiplying them. So that would end up 6. Now if you notice, this is not in scientific notation. It's partially in scientific notation because it's got this correct, but this has 2 numbers to the left of this invisible decimal point, and so we need to convert it. If we move that decimal point over to the left, we are adding 1 to this. Remember, if you're moving it to the left, you're adding to the exponent. So instead of being 64 times 10 to the 6th, we would write 6.4 times 10 to the 7th. And these are identical numbers, but this one is written correctly in scientific format. So let's take a look at the worksheet. Here we've got 2 times 10 to the 4 with the exponent 3. Let me do this one by hand. So we've got this one right here, 2 times 10 to the 4 with exponent 3. So the first thing that we're going to do is we're going to distribute that little cubed, that little 3, to both of them. So it would be 2 cubed times 10 to the 4, and remember for this one we are multiplying it. So what is 2 cubed? 2 times 2 is 4, 4 times 2 is 8. And what is 4 times 3? 12. Okay, so this one, luckily the answer was in scientific notation already, so I don't have to change anything. But here I made sure to remember that this number gets distributed to both of them, and when I'm taking a power up to another power, I multiply the numbers together. Now this next one has a square root, and normally you could just solve this by putting it into a calculator, but I'll show you a way that's actually easier by using scientific notation. Taking a square root is the same as raising a number to a fraction of a power. So the square root of a number is the number to the half power. The cube root is the number to the third power. The fourth root is the number to the fourth power. And so, for example, you have the square root of 100, which you might already know the answer is 10, but with more complicated numbers you might not know it. So if we take a look at this and we see 100 to the half, that's a little bit different. And you're like, oh gosh, how do I work with that? Well, here's that number being applied to this. Remember, you can convert this to scientific notation, 10 to the 2, and that becomes easier. Because you know from the previous slide that if you're raising a power to a power, that you just multiply them together. And so 10 to the 2 is 10, and then we have the 2 times the 1/2. In this case, they kind of cancel out and become 1. But let's take a look at the example that's on your sheet. On the worksheet, we have what is the square root of 2500 or 2500. Now, you might already know what the square root of 25 is, but you might not know what the square root of 2,500 is, and I'll show you how you can use the exponents to help you with complicated ones like this. So the first thing we're going to do is break it up. So what is 25 times 100? It's 2,500, so let's do that. 25 times 100. And so that's the same as writing 2,500. And so now we can say this whole thing is to the 1/2, because that is what we learned a square root symbol is. So if we've got that, we can just take the square root of the first one. So we have 25 to the 1/2, or we could write with this. We could say, let's copy that over since I'm doing this here, the square root of 25. And then we have times 100 to the 1/2. And we learned just recently that since this is 10 to the 2 times the 1/2, what would that end up being? And so this was 10 to the 2, that just means 100. And we're multiplying it by the exponent that we brought it up to, which we learned on the previous set here. So we got 2 times 1/2 is just 1. So we are ready. Equals, what's the square root of 25? 5 times 10 to the 2 times 1/2, which is 1. And so our answer is, what is 5 times 10? And so this might seem like it's a little bit harder to do than just plugging it into a calculator, but there will be times when it's easier to do it this way than it is to put it into a calculator. Speaking of which, you're going to need a scientific calculator to do the rest of this worksheet. First thing that you're going to do when you're using scientific notation in a calculator is you need to find your exponent key. So it's either going to be a capital E or a capital EE or EXP, something similar. And what that key means is times 10 raised to the power of. And that's all that button means. And so you need to find one. Let's take a look at the two calculators I have. On this calculator, it's kind of difficult to find, but you're not looking for the lowercase e, you're looking for the capital E. And in this particular case, it's hiding right there. Do you see it? I feel like Dora the Explorer. Yes, it's right there. Yeah, it's that double E right there. In order to get to that function, like if you just type this, that would be whatever x to the -1 is talking about. But you would type the second button to get to these numbers that are, or letters, functions that are above the buttons. And so if you're going to need to look at your calculator, look and see if you can find that. My other calculator is a little bit easier to use because its exponent button is right here. You don't have to click shift, you don't have to click second or whatever. It's right there and it says exp. So I do have a small set of these in the classroom. If we're having in-class time, you can always use one of those. So find your exponent button first, and then what you're going to do is you're going to write it here. So whatever your scientific calculator, which means it's got things like exponent buttons and pi and stuff like that in parentheses, what does yours look like? So mine looks like this, but on the pink one, it looks like this. It's like the letters above x to the -1. And so I have to type the second key. So if I'm doing that by hand, I'm actually drawing what that button looks like so I can find it. Well, if I'm doing this on the worksheet, I'll type it a little differently. So here I would type maybe with like brackets to show that it's the button, EXP, like that. Or if I'm using the pink one, it would be EE, and then it's over the x to the -1. And I'm just doing that so that I can find it later if I'm like, oh gosh, what was my calculator's button? So what does your calculator's exponent key look like? Go ahead and fill that in there. This next thing that we're going to be talking about are the parentheses. And you'll see here it says always use parentheses to surround a number in scientific notation. And this is because calculators don't follow PEMDAS. So most of you have either learned BEMDAS or PEMDAS. This is the order of operations that you're supposed to go in. And so if you see a problem like this, you know, according to the order of operations, you're supposed to do the multiply symbols first, and then go in and do the addition after. And that's the order of operations. Your calculator ignores PEMDAS, and so it would take 3 times 10 to the 2, and then it would add 2, and then it would multiply it by 10 to the 4. So let's find out what this would be if you ignore PEMDAS. So 3 times 10 squared. So it's either going to be 3 times 10 and then square that, or 3 times 10 squared. Since this is going to be incorrect regardless because we're ignoring PEMDAS, I'm okay with either one. So let's just say that when we see 10 squared, we think 100. So 3 times 100 is 300, plus 2. Okay, so that's 302. And then multiplied by a 1 with 4 zeros, which is 10,000. So 320, nope, let's type it in. 302 plus 4 more zeros. Yeah, so that would be like 3,020,000, something like that. It could even be something even more crazy, like 3 times 10 is 30. 30 squared is 900? And so it would be even more ridiculous. But let's find out what this would be if we ignore the order of operations and we actually add these together. Well, if we put it into a calculator, we have to put these parentheses on either side of this to force it to do it correctly. Now we have learned how to add these, and so we could figure it out by hand, but now that we're using a calculator, why don't we go ahead and do that? So let's solve this first one using PEMDAS correctly, because we're going to be using the parentheses. In order to do that, we need to know how to put a number like this into scientific notation. And so what you need to do is you always start with a parenthesis. You put in whatever the number before the multiply symbol is, so for this one it would be 3. You type the exponent button, which stands for times 10 raised to the exponent, and then you put the number of the exponent. And then you end the parentheses. And so, for example, if we needed to put this number, 2.5 times 10 to the 2, these are the exact buttons that you would click in order to get there. So when you see a number like this, where it says 2.5e2, that e, that exponent, stands for the same thing as saying times 10 to the... So I'm going to show you guys typing this into a calculator. Alright, so here's the calculator. I'm going to start with the parentheses. If you see that here, it's displaying the parentheses there. We've got 3, and then the exponent button, and then 2, and then we end the parentheses. So that 3 exponent 2 is the exact same as saying 3 times 10 to the 2. Alright, so now we can have our little addition button. And I've surrounded this with parentheses to make sure the calculator knows that's one single number all bound up together. So then the other one would be 2 exponent 4. So this looks like 3e2 plus 2e4, and what it translates to is exactly this. 3 times 10 squared plus 2 times 10 to the 4. These are the exact same things, but it actually is simpler just typing it into the calculator than it would be doing by hand. So let's push the equals button, and this ends up being 20,300. So I'm going to write that down for a second. 20,300, which is very different than the thing that we came up with if we ignored PEMDAS, the order of operations. Just for fun, let's put this into scientific notation. So we've got the decimal point here. We got to move over 1, 2, 3, 4. So this is actually 2.03 times 10 to the 4. All right. So I'm going to pause it there, and we're going to talk about this next step. Here, it's asking us, just checking to make sure we know what our buttons do and what order to push everything, but it's asking for us, what would you do to input the number 9 times 10 to the negative 9 into the calculator? So, the first thing that you would do is type the parentheses, then you would type the 9, then you would type the exponent button, so I'm going to use brackets to show that it's a button, like that, exponent button, and then the exponent is negative 9, and so what I would do is, one thing you really have to find is that the negative button and the minus button are actually two different things. So let's take a look at the calculator to take a look at that. So if you notice, here is the subtract symbol. That is not the same as the minus sign. Do you see where the minus sign is? It's up there. So this means, or negative, sorry, even I get the names mixed up. This is negative for negative numbers, while this is a subtraction symbol. Okay, let's see if we can find it on here. We have the subtraction, and then down here we have the negative sign. And so they usually put the negative sign in parentheses like that. And so that's how I'm going to represent it on this worksheet here. So I'm going to show that I'm typing not just any minus button, but the negative sign, which is in parentheses like that. And so 9 is the exponent, so negative and then 9. And then we can end that scientific number by ending the parentheses. And so if you want to separate these so that you can tell that they're different buttons, or if you want to do something fancy like I did up here, if you would like to do something fancy, I can show you what that looks like and how to do that. So if you're typing this into Google on Google Docs, the way to turn this into this is you're going to go to Insert, Drawing, and you're going to create a drawing. And here you have these options, and I used a shape that kind of looked like a button. It had rounded rectangle corners and stuff. And so you just, you know, make it whatever size. I would like to make it a square. And you just type, oh, there's my parentheses. And you're like, it's not, maybe I'll make it bigger, because you can always make the picture itself smaller. So let's make it, let's use size 24 font. Yeah, look at that. That's not bad. That's not a bad button. So I can click on it and then Control-C to copy it, and then I can paste it and then change what's on the inside. So here it looks like I've got two buttons next to each other, the parentheses button and then the 9 button. And so I can actually do this and paste it, and the reason why I'm copy pasting is so they end up the same size, distance apart, and all that kind of stuff. And then here is the exponent button. Now if you notice, that's a little too big, so let's change the font size. And so if you would like to make it nice and cute like this, feel free to do that. Alright, so, and then we've got the negative button, the negative buttons like that, but if it doesn't fit, then we just decrease the font size a little bit until it works. Yeah. And so this way, I can type this in. This one actually was 9. There. And so it's just another way of showing it, and it's good practice to try out these drawing tools that they have here in Google Docs. And so when you're done, you click Save and Close, and now it's a picture, and you can make it as small or as big as you'd like for it to be. So I'm going to go ahead and leave that one there like that, and that would be my answer. This is the buttons that you would click. This is optional. You can draw it by hand or you can type those in by hand, but I highly recommend that you practice with Insert, drawing and try out all of the features in that so you can make your own picture. Taking a look at this next one, it's basically just checking to make sure we know what that E stands for. And so let me do the first two here, and then I'll do this one here, and then I'll do this one on the paper, okay? And so then you guys will do the other one. So here, what this means, 3.01, and the E stands for times 10 raised to the power, and so I'm going to do control period of, and then whatever the exponent is, 24. So it's this here, E stands for times 10 and then raised to the power of. And so 3.01 E24 means this. So I'm going to go ahead and get rid of that one and then show you the other one by hand. So if I'm taking a look down here, I've got 7.4 E25. So that's 7.4 times 10 to the 25. So knowing that the E stands for times 10 to the, or times 10 raised to the exponent of, will help you put it in correctly. I've seen people do it incorrectly where they'll type it in and they'll know that a 10 is involved, and so they'll think that they have to type like 2 times 10 exponent 4. But this is not the same as 2 times 10 to the 4, because the E already has the multiplied by 10 raised to the power of built into it. And so this is like 2 times 10 to the 4, and that's not how you do it. It would be 2 exponent 4. It's actually way easier to do it with the exponent button than it is to manually type it in. So before we move on to the practice problems, let's take a look at this slide, this last slide of the scientific notation notes. And it's got some of the things that I've already said, but a couple hints. So calculators do ignore the order of operations, so you have to remember to always use the parentheses. And one thing that I've noticed is a lot of smartphone calculators even ignore the parentheses. And so you can check to see if your phone has the scientific calculator, but even then it might not be doing it correctly. So what I would do is I would go through one of these that you have used parentheses on a normal scientific calculator, or maybe one that I walk through, and see if you get the exact same answer using the parentheses on your smartphone calculator, because it's possible, most of the ones that I've seen so far, so it's possible your smartphone calculator might ignore PEMDAS even with parentheses. So I highly recommend either borrowing one from the school or getting your own scientific calculator. So the long way of typing it in would be if you actually did the multiplied by 10, and you'd have to find this little caret symbol on your calculator, and even that sometimes looks different in order to get to the 5. But the shortest way is literally just type the number, type the exponent key, type whatever the exponent is. And so that's the short way. You basically just need to find what the exponent key is on your particular calculator. And also don't forget the minus key is not the same as the negative key. Alright, let's take a look at the example problems. So here are the example problems down here. We've got multiply and we've got divide. Now if you look here, there's a reminder to always put things in parentheses. So I've put these first two in each side with parentheses to show you where the parentheses would go, but all the other ones don't show parentheses, but you have to remember to type in the parentheses. And so what I'm going to do is I'm going to do this one. I'm just going to highlight it so I know I'm going to do that one, and I'll choose another one at random, this one. And then I will also do, let's say I want this one, and I'll do this one. Alright, so I will do these, but I'm expecting you guys to do the other ones. So let me show you me typing this into the calculator, and then I'll type the answer in here, and then I'll show you me typing this into the calculator, and then I'll write this one by hand. Alright, so I want to show you both ways. So let's take a look. So for this first problem, we're starting with parentheses 2 and parentheses. You don't actually need to put just the number 2 in parentheses. I just find that it's good practice. And then we've got the multiply symbol. And then we've got 2.5 times 10 to the 2. So we begin parentheses, 2.5, exponent, 2. We end the parentheses, we double check, it looks good, we type equals, the answer is 500. So the answer to this one is 500. I would accept that as the answer, but if you want to put this into scientific notation, that would be 5 times 10 to the 2. Alright, so let's write that in here. The answer is 500. Or you could write it as 5 times 10, control period, to the 2. Alright, let's do this next one down here. This one is similar. It's actually very similar. So let's clear this. Start parentheses. This time we've got 2.5. End parentheses. Multiply. Begin parentheses. 2.5. Exponent 8. End parentheses. Alright, so that is this one right here. Push equals, and the answer is big. So I could type it like this, where it says 625. And then it has 6 zeros. Alright, now this calculator I have set to just show me the number that way. It's possible that some of your calculators might default into showing it to you already in scientific notation. So either one would be correct, but let me show you what this would be with scientific notation. You take this decimal at the end, and you move it until there's only one digit to the left of the decimal. So how many digits does it have to skip in order to get there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so we would end up with 6.25, and then you can ignore the rest of the zeros. 6.25 times 10 to the 8. Alright, and I'll type that in as well just to show you guys what that looks like. 6.25 times 10, control period, 8. Alright, let's try the divide ones. So the first one that we're going to do is the 7.2. So let's take a look. This one right here, let's go ahead and clear the calculator. And we've got, in parentheses, remember, begin parentheses, 7.2 times 10 to the 5, which would be 7.2 exponent 5, end parentheses. Now this one has a divide, so this entire side is asking you to divide the numbers. So now we have the divide symbol, and begin parentheses. And now we've got 5.7 times 10 to the 4, so 5.7 exponent 4. I should be able to push equals, and I get that long number. Now, a general rule for me is I only really need 3 and at max 4 numbers after the decimal point. And so for this one, let's just go with 3, but we're going to have to round it in order to do that. So this is 12.631, but the 1 would round up to a 2 because the 5 is 5 or more. So the answer for this one is 12.632. And we don't need to put that one in scientific notation. Alright, and then this last one that I said I would help you guys with is also on that side, but let me check. It's the second to last one. It's got some 24s and some 22s, and so it looks a little complicated, but let's figure it out. So, one trick that you can do is anytime you see a number in scientific notation, just automatically draw yourself some parentheses around it to remind you that you need to be putting parentheses around these. Alright, and don't forget this is a divide symbol, and let's put that in clear, the calculator, and I'll have it where it's in view the entire time. Parentheses 6. Now this has 6.0. You could type that. It doesn't matter right now, but we have 6 exponent. This is 10 to the 24. End parenthesis. Remember that this is a divide problem. Begin parentheses. 4.6. And this is times 10 to the 22. So that is exponent 22 in the calculator. Let's end the parentheses and push equals. And this one is 130, 130, and let's go 3 digits after the decimal point, which would be 434, except the 4 would round up because the next number is a 7. So 435. So in general, I'll usually ask you to do 3 digits after the decimal. So let's go ahead and put that into our worksheet. This one is 130.435, while this one up here was 12.623. Nope, 632. I messed up. There we go. So, once you're done with that, you're going to do all of the other problems. Don't forget to put in the parentheses, and you guys should be all right. Let me know if you have any questions. And feel free to go back and watch parts of this video whenever you need reminders. Thank you, and I'll see you in the next video.